Hello, welcome to the second session of Unit 9, which is the theory of costs. My name is Elias. So in this video, we are going to continue with the theory of the firm and then specifically look at the per unit costs as well as the marginal costs. So to start with, we can start with the average fixed cost, which is simply the fixed cost incurred per unit of output produced. In other words, this is the cost that the firm will incur at any given level of output. So we want to measure how much each of the output produced will cover or will take up from the fixed cost. So it's simply the fixed cost divided by the output that the firm has produced. In an equation form, average fixed cost is equal to total fixed cost divided by Q, where Q is the output that the firm has produced. Let's assume a total fixed cost of 100 and the output level of 2, which means we have 100 on the numerator and 2 in the denominator, meaning what we have then, this will be 50, which means that our average fixed cost, which is the fixed cost per unit will be 50. Therefore, given this, you should note that the more the denominator increases, given the numerator, which is simply the total cost, you will notice that this ratio will be declining. Therefore, it should be concluded that the average fixed costs decline along the entire average fixed cost curve. Okay, now you should also note that this curve will not cut the horizontal axis, but rather it will be approaching the horizontal axis asymptotically. So it will not be equal, or it will not touch per se to be equal, but there will be at least a gap between the horizontal axis and the average fixed cost curve. Okay, let's look at the average variable cost curve function. So the average variable cost is the total cost, the total variable cost incurred per unit of output produced. What this is that this average variable cost is simply the total variable cost divided by the firm's output. How many units the firm has produced and how much has it spent on bringing in the inputs. That expenditure on the input or resources brought into the production to produce a given level of output is the total variable cost. When we divide the total variable cost by the output produced, we get the average variable cost, which is the average the variable cost per unit. In an equation, the average variable cost is equal to total variable cost divided by Q. Now, it should be noted that the average variable cost initially falls because of increasing marginal returns, but then later on it starts to rise because of the diminishing marginal returns. Now, when the firm is experiencing increasing marginal returns, it means the total product curve, or rather the total product, is rising at an increasing rate. And the time the firm starts to experience diminishing marginal returns, it means that the firm's production is rising at a diminishing rate. Therefore, when the firm is producing, the firm's output is rising at an increasing rate, its average variable cost will be declining, meaning its cost per unit will be declining the more the production levels. And after a given level, if the firm continues to hire resources, it means that the average variable cost will then start to rise at an increasing rate. So whereas the total product will be rising at a diminishing rate, the average variable cost will be rising at an increasing rate. Let's look at the average total cost. So this is the total cost incurred per unit of output produced. And from this, we note that it is simply the ratio of the total cost divided by the output, which is Q. In the simple illustration where we bring the average fixed cost and the average variable cost, our average total cost will simply be equal to the average fixed cost plus the average variable cost. And with this, then, we note that any figure, if you know what your average fixed cost is and what your average total cost is, then you can get your average variable cost by simply rearranging this equation. With this per unit cost description, let's turn to the marginal cost. The firm's marginal cost is the extra or additional cost of producing one more unit of output. That is, it is the extra cost incurred in producing an extra unit of a given commodity. Simply put, the marginal cost is simply the change in the total cost divided by the change in output, or the derivative of the total cost function with respect to the output produced. Now, because in the short run, the firm's total cost is equal to the variable cost, the changes in the total cost is equal to the changes in the variable cost, it means that the marginal cost then is simply the change in total variable cost divided by the change in the output. Now, by change, if you recall from other units that we've looked at, it means we are measuring TVC2 minus TVC1. So let me do that here. So this is simply to say TVC2 minus TVC1 divided by Q2 minus Q1. So we have our Q2 here minus our Q1. So this is the marginal cost measure. Okay, so now if you notice what I've put here, I've already explained why we have marginal cost in the short run being measured with total variable cost and the output changes. Let's turn our focus to the cost schedules. So on this cost schedule, we have the output, the total fixed cost, the total variable cost, and the total cost. And these are the ones we saw in our previous session, which was simply on the introduction to the cost functions. So all this is something that we have already looked at. So what we've added now is the average fixed cost, the average variable cost, the average total cost, and the marginal cost. So with this, we can look at this. So if we start with the average fixed cost, when the firm has produced 0 units, the firm will incur 100 kwacha, which is the total fixed cost. Now, because total fixed cost has to be incurred regardless of whether the firm has produced or not, and because it is fixed, it means that throughout the production process, total fixed cost will be constant at 100. Therefore, the average fixed cost will simply be the total fixed cost divided by the output. For 0 output, it will be undefined, so we simply put a dash because a number over 0 will be infinite. So for the simplicity, we'll simply say you will not be able to have a definite figure, so put a dash. At the first unit of output produced, our total fixed cost is 100. So if we divide 100 divided by 1, we get our average fixed cost of 100. For our second unit of output produced, our total fixed cost is 100. So if we divide 100 divided by 2, we get 50, which now happens to be our average fixed cost at the second level of output. If we have 3 units produced, we will have 33.33 as our average fixed cost. So I give you an exercise, try to calculate all these fixed costs and come up with these associated average fixed costs. The next that we have is the average variable cost. Now when output is 0, our total variable cost is 0. With this, 0 divided by 0, it will be undefined, so we simply put a dash. Now, when the firm has produced a unit, it means now the variable costs will start going up, because what has led to that production is that the firm had to spend on variable inputs which can be used to boost the production process. So at the first unit of output, our total variable cost is 90, and therefore our average variable cost will be 90. If we have 2 units of output produced, our total variable cost becomes 170, meaning that our average variable cost will be 170 divided by 2, which will be 85. So we do the same for all these values and verify that these are the values that you'll be getting for the average variable cost. If we move on to the average total cost, now we said this is equal to the total cost divided by the output. So when output is 0, our total cost is equal to 100, which is equal to the fixed cost. At 0 output, our average total cost will be undefined, so we put a dash, or will be infinite, so we put a dash. If the firm produces 1 unit of output, the total cost becomes 190, which is simply the sum of the fixed cost plus the variable cost. So you have 190, and the average total cost will be 190 divided by 1, which will simply be 190. And for the second, if the firm has produced 2 units, the total cost is 270, 100 of fixed cost plus 170 of variable cost. So 270 divided by 2, we will get our 135 as our average total cost. So you can do you can solve the rest and verify that these are the values that you are getting, and keep your answer to 2 decimal places. Okay, the last thing we have here is the marginal cost, which is the additional cost that the firm incurs for producing an additional unit of output. Now, when output is 0, our marginal cost will be 0 because we are not producing, and therefore we are not incurring any cost. The moment we start producing output, our marginal cost will also start to change. We'll start seeing numbers appearing in the marginal cost column. For example, at the output level of 1, our total cost is 190. This means our marginal cost will be equal to 190, which is total cost 2, 190 minus 100, which is total cost 1, divided by the output of 1, which is Q2, minus 0, which is Q1. And if we solve this, we'll end up having 90. So meaning our marginal cost at the first unit of output is 90. For the second unit of output, our marginal cost will be 80, obtained by subtracting 270 minus 190 divided by 2 minus 1. And this will give us our 80 here. For the third unit of output, it will be 140 minus 270 divided by 3 minus 2, and the answer we'll get is 70. So our marginal cost will be 70 for this level. So you can do the same for all these numbers and verify that these are the marginal costs that you will get. Okay, so let's now look at the graphical illustration of these curves. Okay, so here we are. Now let's start by putting our vertical axis and our horizontal axis. So on the vertical axis, we put average fixed cost, the average variable cost, the average total cost, and the marginal cost. With our horizontal axis, we put the total product, which is the output produced by the firm. Now, our average fixed cost curve is downward sloping, and it will be approaching the total product curve asymptotically. This is because the denominator, which is total fixed cost divided by the Q in the denominator there will be increasing whilst the numerator is constant, and this will cause the whole ratio to be reducing. So we have total fixed cost divided by the output Q. So this value, this denominator here will be increasing, because when you are increasing your output levels, it means that the Q here is increasing. And because the numerator is fixed, the whole ratio will be declining. Therefore, the average fixed cost curve will be dropping throughout the curve, and it will be approaching the horizontal axis asymptotically. Okay. Let's look at another curve, which is the average variable cost curve. Now, the average variable cost curve will start by declining, reach a minimum, and then start to rise. Now, the period when the average variable cost curve is declining, this is a period when the firm is experiencing increasing marginal returns. And when the average variable cost curve is at minimum, the firm has reached a point where it's about to change from rising at an increasing rate to rising output at a diminishing rate. And when the average variable cost curve is going up, it means this is a period when the firm is experiencing diminishing marginal returns to a variable factor that it is bringing in the production process. Associated with the average variable cost is also the average total cost. Now, the average total cost curve is simply the curve drawn from the ratio of the total cost divided by the output. Now, because the total cost increases as you are increasing your variable cost, then the average total cost curve will be similar to the average variable cost curve. And the gap between the two, that is the gap between the average total cost and the average variable cost, is equal to the fixed cost here. So this gap in between here is measuring the average fixed cost of the firm. You will notice that as the average fixed cost curve is dropping and approaching the horizontal axis in an asymptotic manner, the average total cost and the average variable cost curve will also be drawing closer to each other. Therefore, when the average total cost is reducing, the firm will be experiencing increasing marginal return. The firm will start experiencing diminishing marginal returns when the average total cost curve is still declining. And when the firm starts increasing output at a diminishing rate, you will notice that there will be a part of the average total cost that will still be declining until it reaches the minimum. Now, at the minimum, I'm going to show you the relationship between these curves that we have here and those of the product curve, so that you understand well how we are measuring this and how they are linked to production. For now, let's keep it in theory that the two curves have the same Nike kind of a shape, and that they draw near each other as you increase on your output levels. Added to these curves is the marginal cost curve, which passes through the minimum of the average variable cost and the minimum of the average total cost. In summary from this, the marginal cost curve cuts through the average total cost curve and the average variable cost curve at their minimum points. So you will notice here that this part here is a minimum point of the average variable cost where it's meeting with the marginal cost, and this point here is the minimum of the average total cost, which is the point of contact between the average total cost and the marginal cost. So the marginal cost curve meets the two curves at their minimum, and the marginal cost curve cuts both the average variable cost and the average total cost from the bottom. That is, it comes from down, cuts, and then go up. Secondly, when the marginal cost curve is below the average total cost, then the average total cost will be falling. So look at the average total cost curve here, the one in red. When the marginal cost curve is below, that is in this region, this part is above the curve and this part is below the average total cost curve. So when the marginal cost curve is below the average total cost, you will notice that this side, the average total cost curve will be dropping. The time the two are equal and then the marginal cost curve cuts to go up, you will notice that the average total cost curve then will be rising. Or simply put, when the marginal cost is above average total cost, the average total cost will be rising. So in this region where marginal cost is up, the average total cost will be rising. When the marginal cost curve is below the average total cost, the average total cost curve will be falling. Okay, in addition, when the marginal cost is below the average variable cost, the average variable cost will be falling. So now let's move to the yellow line. When the marginal cost is below the average variable cost, so that this is the average variable cost curve, and below this average variable cost curve, we're looking at the region this side. So when the marginal cost curve is below the average variable cost curve, then the average variable cost curve will be dropping, so it will be reducing. They will meet, the two curves will meet at the minimum of the average variable cost curve, and then the marginal cost will cut going up. The time the marginal cost curve goes above the average variable cost curve, the average variable cost curve will be rising. Simply put, when the marginal cost curve is below the average variable cost, the average variable cost will be dropping. When the marginal cost curve is above the average variable cost curve, the average variable cost will be rising. Notice also the gap, that this gap here will become, the gap between average total cost and average variable cost will be becoming smaller and smaller the more output you are producing. That is, the average fixed cost curve will be all dropping and dropping closer and closer to the zero line. Okay, so now it should also be noted here that the level of output that the firm produces when it is operating at the minimum of average total cost curve is called the efficient scale. So this output level from this point going down here, which we can call QE, is called the efficient scale. So the firm will continue producing up to this point, and when the firm is here, it has reached the efficient scale, and then beyond this, the firm will start incurring increasing average total costs. Okay, so now let's turn our focus to look at the shifts in the curves. So let's begin with the increase in the fixed costs. Consider the initial graphs that we drew. So consider the cost functions, which are initial costs, where we have the average fixed cost, the average variable cost, the average total cost, and the marginal cost. This time around, we want to consider the changes or the increase in the fixed cost. Now, what will cause the changes in these costs is mainly the resource price, if the price has changed for the resources, or there is a change in technology. If technology has improved, it means the firm will have to incur huge costs to adopt and adapt to the new technology. And if the factor prices are high, it means the firm will have to pay more to get the same level of factor inputs that it was getting. Therefore, changes in the resource price and technology will change the cost functions. For the fixed cost, if the firm has seen a new plant where it wants to build and then incurs a cost in building that plant, it means the fixed cost will increase. And the increase in the fixed cost will mean that the average fixed cost will also rise. With this, we will have an upward shift in the average fixed cost curve to the new average fixed cost curve prime line, which is the dotted green curve here. Now, if you again recall our equation that our total cost let me say average total cost, okay, is equal to average fixed cost plus average variable cost. So if the average fixed cost has increased, it means that the average total cost will also increase. However, the average variable cost curve will not change. It will be unaffected. So with that, then what we have is that our average total cost curve will also shift upwards to the new average total cost prime curve, which is the red dotted line. From this, it should be noted that the marginal cost curve will not change because marginal cost responds to the changes in the variable cost. And the average variable cost curve will not change because no variable costs have changed. Okay, let's now look at the changes or the increase in the variable costs. With our initial cost curves, an increase in the variable cost will also increase the average variable cost. And if that happens, our average variable cost curve will shift upwards to a new level, and we call this the average variable cost prime. From the equation that total cost is equal to the total fixed cost plus total variable cost, and that the average total cost is equal to average fixed cost plus average variable cost, an increase in the average variable cost will increase the average total cost, but it will leave the average fixed cost unchanged. This means that our average total cost curve will also shift upwards to the new line, which is average total cost prime. Now, because marginal cost is a function of average variable cost, remember we said that our marginal cost is equal to change in total, we are in the short run, so change in total variable cost divided by the change in output. So if this part here has increased, holding output constant, it means that the marginal cost curve or the marginal cost will also increase. As such, our marginal cost curve will shift left upwards, and the curve will go to the new level, which is the marginal cost prime. Therefore, it should be noted that the new dotted lines are similar to the old ones that we had, and that the theory should still hold that the marginal cost curve should cut the average variable cost curve and the average total cost curve from the bottom, and that when marginal cost curve is below the average variable cost curve must be dropping, and when marginal cost curve is above the average variable cost curve, the average variable cost curve should be rising, and so is the situation with the average total cost curve. Note also that since average fixed cost has not been affected, the average fixed cost curve will not change and it will remain constant. Okay, so thank you very much for watching. If you have questions, please drop me an email using moauelias@gmail.com. Thank you very much for watching. See you in the next video.